All right, these are the notes for 1.4. The exploration you should really do on your own, but I do want to point out what you notice is that both of these equations end up being the same. If you plug x in, if you plug this value in for x right there, and you solve for y, you'll get, I'm just going to tell you this first one, you get -3. Okay, and you plot that point. You go x value is -2, and then you go down 3. There's your point. Okay, do that for each. You plug in 0 for x, solve for y, and you get these other numbers, plot the points, and you make a straight line. Then you do it for this one. You plug in -2 for x, okay, and you fill out this table. What you'll notice is that your points end up being exactly the same. So you get the same lines. So you compare the two, the similarities of the two equations and what happens, and then the contrast is what's different about them. Okay, the one on the left, I will tell you, that is standard form. That's a standard form of a linear equation. The one on the right is what we call slope-intercept form. Okay, and the thing to pay attention to is I'm sorry, I can't even talk. Why would rewriting an equation solved for y be useful? So if I take this equation and I solve it for y, why might that be easier? So this whole 1.4 is all about rewriting equations and solving for a specific variable. And in this case, when you're plugging them in and solving, which you should do on your own, you'll see that this one, once you plug in, then you still have to do some adding or subtracting to one side and dividing to get to that y. If you plug in to this equation, you can just punch it all in your calculator. You get 1/2 times -2 minus 2 and push enter, and it gives you your y. So it makes it a lot easier to find values. And also when we start graphing lines, this one is much easier to graph. That's actually the line that we graph the most often in the equation. So that is one reason it will be useful solving for y before you do anything with an equation. So now you don't always have to solve just for y. But in these three equations, it doesn't have instructions here. Sorry. But we are going to solve these three equations for y. Okay. So I'm trying to get this y all by itself. So I move anything that's on that same side of the equal sign. So yeah, there's my equal sign. So anything on this side, I need to move to the other side so my y can be by itself. So in this case, I need to move that 3x. Well, it's a positive 3x, so I'm going to subtract it. So I'm left with a -4y. Now, you cannot combine a -8 and a -3x. One has a variable and one does not. So because all of these equations today have more than one variable, you will end up with an equation. You can't try to get this down to one number. So I always write the variable first. So in this case, it's a -3x, and I still have a -8. Now, you do not have to write it that way. You're not wrong if you put -8 minus 3x. But as we get into different equations and down the road when we do polynomials, writing them in order is very important. So it's good to get in that habit of writing the variable before the constant and having the constant be the farthest right number. All right, so now I still need to solve for this y and get this y all by itself. So I'm going to divide by a -4 because it's being multiplied, and that's the inverse operation. So these cancel, and I have y. Now I have a -3 divided by a -4. Well, negative divided by negative makes a positive, and I'm just going to leave it as 3/4. That doesn't simplify. And I still have x. Now, you can still write this as 3x over 4, but again, once we start using these equations for graphing, you want that fraction in front of your x. All right, and then I have a -8 divided by a negative, which negative divided by negative is a positive. 8 divided by 4 is 2. So here is this standard form equation written when we solve for y. So number 2 is the same thing. I'm going to solve for y. So I must first move this 15. Okay, these ones cancel, and that's going to leave me with a negative 4x plus 15 equals a negative 5y. Still need to get that y by itself, so I'm going to divide by that negative 5. And you must divide every single term, if I didn't say that in the previous problem. Okay, not just one term on each side. So, and then these ones cancel. Now, I like writing my variable first, so I'm going to move this over and just write it first. Still equals the rest of this, so it doesn't matter which way, they still equal the same thing. So I have a negative 4 over a negative 5 becomes a positive 4 over positive 5x, and I have a positive 15 divided by a negative 5 makes negative 3. So there's my equation. Now again, I'm solving the y. Well, this one's much easier. I only have that 4 on that side, because don't try moving something else. There's the equal sign, so I'm only moving things that are on that side with my y. So I'm going to divide by a 4 to each term. And again, I'm going to write my y first, so I have y equals, and then I write my x first. So that's a negative 1 over 4, and I still have x. And a negative 12 divided by 4 is a negative 3. Okay? So now on the next page, we have these sets of problems. But this time, all of these, I want us to solve for x. Okay? In the practice, you're just going to be asked to solve for different variables. And there's even a few problems where there's no numbers at all. So your equation will be some variable equals an equation with a bunch of other variables. It's the same thing. You're just moving things the same way. You just may not have numbers in it. All right, so for number 4, if I'm solving for x, I just need to divide everything by negative 6. So negative 6x divided by negative 6 is a positive x. And then I like to write the variable first. So a 3 divided by negative 6 is a negative 1/2. And then a 6 divided by negative 6 is a negative 1. All right. Now, 5 looks a little different. I'm still solving for x, but everything is on one side. So instead of moving the negative 2y and the negative 4 to the other side, I'm just going to move the x. So I'm going to minus 4x from each side. So I get a negative 4x equals a negative 2y minus 4. And now I just have to divide by that negative 4 in front of my x. Now there's multiple right ways to solve these. So if you do it slightly different, move different things, as long as x ends up on its own, by itself on one side of the equation and everything else is on the other, you're good. But I'm trying to show it to you with the least amount of steps. So these ones cancel, and I have x equals a negative 2 divided by negative 4 is 1/2. Negative 4 divided by negative 4 is a positive 1. Okay. 6 is similar. I'm actually going to cut down to number 7, because as soon as people see fractions, they freak out just a little, but you shouldn't. It's the same thing. Now we're solving for x, so I need to move this 1 over before I do anything else. So I have 7 over 4x equals a negative 1/4 y. Whoops, that's a y. It looks like an x. That's a y. Minus 1. Okay? Now, I have to divide by a 7/4, and we do not like dividing by a fraction, so I actually end up multiplying by 4 over 7 by every single term. So I'm going to just rewrite this just because it makes it easier. These I know cancel. And this other side, I'm going to have 4 over 7 times a negative 1/4 y minus, that's a minus sign, so 4 over 7 times 1. Okay? Now, I write it like this because with fractions, if you have a number on the top and on the bottom, they cancel out to 1. So I have a 4 here and a 4 here, so they canceled. So if I put that together, I end up with x equals, I have a negative 1y, and then I have basically a 1 over 7. So I'm going to have a negative 1 over 7y. You can't bring that 7 to the top, so just make sure it stays in the in the denominator. And then over here, I have a minus 4 over 7 times 1. Well, anything times 1 is itself, so I have 4 over 7. All right, and you do the similar thing for number 8, and then number 9 is like what we've been doing as well. So you can do those 3. So those are the notes for 1.4.